And this question is given that two different materials have a coefficient of thermal expansions, that is alpha 1 and alpha 2, and the Young's modulus, so this one is given as alpha 1 and alpha 2, and Young's modulus is given as nothing but y1 and y2 are fixed between two rigid walls. The rods are heated such that they undergo same increase in temperature. So we can write the value of delta T in the first situation and delta T in second situation are same, or you can write there in the ratio 1:1. Same increase in temperature. There is no bending of rod. If alpha 1 is to alpha 2 is given as nothing but 2:3, and thermal stress developed in the rods are equal provided y1 is to y2. So RM is to find out the value of y1 is to y2, and it is given that the value of thermal stress is nothing but force divided by area in the first case, and force divided by area in the second case are same, or they are in the ratio 1:1. So we know that when a metal rod is heated while keeping it between two rigid support, then this thermal stress is going to develop, and we know the equation for this thermal stress. So we'll write that thermal stress is equal to nothing but force divided by area, or by the equation of Young's modulus, y is equal to stress, that is force divided by area, by strain, that is change in length divided by original length. So the equation for Young's modulus is F into L divided by A delta L. So if you are just calculating the value of this F divided by A, so we can write that is equal to nothing but y into delta L divided by L. Now this delta L is happening due to thermal expansion. So another delta L is equal to initial length into alpha into delta T divided by initial length L. So this L get cancelled. So we'll get the equation for thermal stress is y into alpha into delta T. So in question it is given that these thing is equal in both the situation. That means F by A is equal in both the situation. So we can say that y1 alpha 1 into delta T is equal to y2 alpha 2 into delta T, and same delta T, so we can cancel these two, and we can write the value of Rm is to find out the value of y1 by y2, which we can take it as something but alpha 2 divided by alpha 1, and the value of alpha 1 is to alpha 2 is something but 2 by 3, so we can write this as something but 3 divided by 2, or they are in the ratio 3:2.